Alright. Let's get started. Oh my god, I haven't streamed in such a long time that I've forgotten how to do this. Hello, everybody. Good morning. Speeding at sea. It's me, Z. I hope everybody is having a spectacular, epic, amazing morning, or evening, depending on what time zone you're in. Okay, let's quickly do attendance. Hello, Ricardo Berrigan. Hello, Professional Skill Issue. Hello, Astro Atropos. Hello, Atlas Chainsteel. Hello, Pun Pundit. Hello, Isaac. Hello, Mindforce. Hello, Cinna. Hello, KK1. Hello, Call. Hello, Kronos. Hello, everybody. I hope everybody is having an amazing, epic week. I can't believe it's been over a week since my last stream, I think. Things have been really crazy. Hello, Mindforce. Just to give a bit of context, like, this past week, I've been up to shenanigans. So, I was on a business trip this past weekend. So, I was out of town, away from everything, and it was amazing. It was so much fun. I also encountered a shop with a heck ton of Hololive merch, and I got an Ina pin, which was really cool. I actually should send more photos on the Discord. I ate some amazing okonomiyaki. I ate some pretty decent airport coffee, and so on. It was a great time. Yeah, Ina. Yeah, no, it was so adorable. I think I'm actually going to start collecting the Hololive pins because I have Ame and Ina now. So I gotta collect them more. And this past week, we gained so many epic new Orbeez. I posted on Reddit and it actually went quite viral. And, if you are new from that, welcome to the channel. Hello there. Welcome to the Orbeez. What has everybody been up to this past week? I feel like it's been quite a bit. I'm a Takodachi of culture. Exactly. In fact, I think I'm just a Hololive Myth stan. Yeah, I don't have many Holo merch near me either, but when I went on that epic business trip, I ran away from the group I was with to sneak into a Hololive store, and I was at the cash out register, but it was really overpriced. So I was at the cash out register with like 7 things in my hands, and they were like, yes, the total cost will be like $50. And I was like, what? I just have a few stickers and pins. How can that be? And they're like, yeah, the stickers are like $7 each. The pins are like $8 each. I was like, what? And so I ended up just getting one pin. And it was this like one where you can get a random one. And I opened it up and it was Ina, which, well, I feel like I would be happy with any Hololive Myth member. Yeah, 07 to Ame. Ame was actually my my Oshi in Hololive. Mindforce, congratulations on the new job. I think that's what you're trying to say, or jorb. I guess it's like Orbeez, but like job. Congratulations. Hello, PogChamp Senpai. Hello, Isaac. Yes, investigator. But I do have to say, I'm watching Doobie's content with newfound interest. Op-amps. Ooh, stickers for $7? Yeah, no, I had like a Suisei sticker, I had an Ame sticker, and I think they racked up the prices on the Ame stickers too, which made me really upset. But the pins were really reasonable. I think the pins ended up being like $6 to $8, which I think are pretty reasonable. I actually also have like a pin making machine, so if I have time, I might actually just make Hololive Myth members in my engineering lab. I live in Europe, there are no VTuber merch stores. No! When I went to Japan, there were so many. But also, when I went to the business trip, there was actually quite a bit too. Did you get an Amebi plush? The plushies were even more overpriced. The plushies were like $30–40, and it was these tiny ones. Taco and an usagi, yes. Yeah, no. I feel like the pin prices were reasonable, and I think I can start collecting them. I'm actually putting them all on one bag, so if you're just walking around and you see an individual with an Ame pin and an Ina pin, that's me. A Rusia figurine. Oh, that must have been really rare. No, that must have been really, really rare. Woohoo! Oh, I need a good stretch. Yeah, but what has everybody been up to this past week? So, I'm going to chat more about this later alongside the super duper special announcement, but this is actually going to be my last stream before Thanksgiving break. So, I will be gone for a week. I'm actually flying to like my childhood home and going to be relaxing, going to be with my family and my family's dog. It's going to be an amazing time. I will take many pictures of my dog, which I have named Doge, by the way. Doobie is a surprise guest at the Doki Bird Made Mint. What? Where is the Doki Bird Made Mint concert? Oh my god. It's in Atlanta, Georgia. That is very far from me, considering that I'm in the Pacific time zone. Wow, that must be so cool. I hope somebody here at least gets to visit. Yeah, no, I'm a little sad I'll be away, but I feel like also one of the reasons why I haven't been able to stream as much this week is because I have been really backed up with work. A few days ago, I pulled like 2 almost like all-nighters. I was really exhausted. I was low battery mode. It was really tiring. But last night, I felt like the past 2 days have been great. I feel like the work's slowing down in advance of Thanksgiving now. So I feel like the work rushes up because people need to catch up before Thanksgiving, and then it slows back down. Yeah, and then like a few nights ago, I got like a good night of sleep. Last night, I got a good night of sleep. And then I also had Chipotle for dinner last night, which I feel like automatically rejuvenates my health. Like the chips with guac is just so fire. Just uni work. Q4 deadlines. Yeah, no, must be really intense. Experiment finding normal modes like 20 minutes ago. Ooh. Oh, hello, Nep. Yes, it is announcement day. I am so absolutely stoked for the announcement. Okay, so maybe one thing that I've been working on this week is not only planning this live lecture, but also planning for this epic announcement. For context, this announcement has been something I've been working on. I feel like I started like maybe like within a month or two of starting my VTubing journey, and has slowly ramped up, and these past few weeks I've been really working on this epic announcement. Taco Bell for dinner and it fought back. Ooh, I have to admit, I don't like Taco Bell. Maybe I'll get canceled for this, but I actually do not like Taco Bell. I really like Shake Shack though, if any of you guys have tried that. That's like the only burger joint that I can handle. Even when I go to McDonald's, I can't get hamburgers. I can only get like fries, which I'm addicted to, so. Turkey and mashed with gravy, yes. I'm so ready for like a homemade dinner. So I will be gone, but I'll be sending a lot of photos. If anything, I'll have more time to send photos of a lot of the homemade cooking I'm going to be doing at home. My family's going to be there. It's just going to be a great time. Yes. Yeah, no, Chipotle is really like, it is my health bar. It just rejuvenates it immediately. Are you a bowl or burrito person? I am definitely a bowl person. I feel like the bowl is pretty great. It's also very easy to save for later. Hi, Nep. I'm gonna hang out and listen in for a while. Yes, if any of you guys haven't already, go subscribe to Nep. I think Nep is primarily on Twitch. She does like botany content, science VTubing, very epic. Shake Shack is goated. Yeah, no, Shake Shack I feel like is the only burger I can eat. Do you have a dish you often make for Thanksgiving? I really like making, I mean, my family does like a turkey usually. I think we might even switch it up this year just to make it easier. Mashed potatoes, yes. Gravy, yes. Cranberry sauce, yes. It's just the whole shebang. But I think the one thing that I'm looking forward to most is my mom and I. Z's mom mentioned. What? 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 Z has a mom? What? Z wasn't born from the universe? Absolutely revolutionary news. Do you have a dish I make often? Yes. So I like to make sangria wine with my mom, which is great. Mama Z? What? I know, I'm sorry. I'm not following canonical lore because it's not I was not born from the universe. Mama Z. Mama Z actually travels faster than the speed of light. No, I'm just joking. Z Omega mom. Zom. Zom. That's crazy. Yeah, so I'm looking forward to making this like really delicious like sangria wine. Stop. No. I mean I have to say we do make a non-alcoholic version as well, which is probably more healthy. Hello, not why. Yes. So I'm very excited to make sangria. I'm also just excited to see my family's Doge, which my Doge is like 1 or 2 years old. He's just a puppy. I named him Doge. Is it like a mulled wine? Yeah, basically. We make it quite spicy, so I guess it's not really a sangria, but probably more like a mulled wine. Yeah, that's a better word for it. But yeah, let me know what you guys like to make. I feel like I also need some more ideas. I've also been playing around with like charcuterie and making like really nice appetizers. I think we're going to have some. I think my grandparents are also going to maybe visit. We'll see. So I really want to make some like really good appetizers. I love cheese. Cheese is the best thing ever. So I'm actually lactose intolerant, but I oddly don't get a reaction to cheese. Isn't that odd? I like glog wine. What's that? In undergrad, we would make big vats of sangria. Wait, that's crazy though, because I feel like you need a lot of ingredients, like fruit. Fresh fruit is not easy to obtain. Cheese is low in lactose. Yeah, and it's also very processed. I'm also mostly okay with pizza. My issue with pizza is that it might be due to the lactose reaction, but I get full really quickly. I can only eat like one slice and then I'm like full. But I can't drink milk. That's the big issue. So I always have to get soy milk, which costs like an extra $1 for coffee, but it is what it is. Actually, Starbucks recently announced that they're reducing the additional price for to add soy milk to coffee, which I feel like is really good. Frozen fruit. Ooh, smart. Wait, that's actually really smart. We make glue wine. I don't think I even said that right at all. I'm jotting these down, by the way. German mulled wine. Ooh, that sounds really good. Speaking of Germany, okay, I'll talk more about this later. I don't want to spoil too much about my travels, but later in the year. So I'm going to be back for Thanksgiving. Going to be back for 1.5 weeks. So not a lot of time. And it's also going to be a really busy 1.5 weeks. So maybe not as much time to stream. But after that, I'm going on my long break. And I know I've mentioned this before, the long winter break, as if it's some sort of like big bad news. It sort of is, because I'll be gone for like 3 weeks, which is really great because I feel like I really need to rejuvenate myself. And I will also still be posting videos and stuff like that, but I will also be traveling to Europe. Actually, oh, Mind Force, my family's Norwegian. Ooh, I did not know that. That's really cool. One of my friends would get those big specialty popcorn bins from her parents. What? That full of sangria? That's not healthy. I dislike. I laugh as if I didn't do the same. Here in the UK, we don't do Thanksgiving. So what's the difference between Thanksgiving dinner and Christmas dinner? I think Thanksgiving dinner is like, you usually eat turkey, you usually eat mashed potatoes. It's also like, I guess it's sort of like Christmas dinner, but I think you tend to invite family. Sometimes people invite like friends too. It's just like a big social dinner. Actually, speaking of the UK, I'm actually visiting London as part of my travels in the winter break. So that'll be really fun. I love Christmas in London. It's snowy. Well, it's not snowy, but they have like these like angel lights up, which is absolutely gorgeous. It's really beautiful. It's a little chilly, but they have really good hot chocolate. There's this place called Knoop's that I'm addicted to. They make hot chocolate and you can adjust how dark the chocolate is. Have you tried Fairlife Ultra Filtered Milk? No, I have not, but I've actually been recommended it quite a few times. I lived in Norway for a short while. Ooh. Undergrads live in an unhealthy manner? No, not at all. Undergrads are the most healthiest population on the planet. Yeah, turkey, stuffing, rolls. Yes, stuffing. I forgot about that. Mashed potatoes and gravy, cranberry sauce, sweet potatoes. Pumpkin and apple pie, 1000%. I might actually try to get like a nice fruit cake. Whole Foods is probably the best place, so yeah. So stoked for Thanksgiving. I kid you not. I have never been excited for something more. I think also, I have to say the past week has just been really challenging on my like physical health. So I'm just excited to go home, rest, be with family, do work, but also balance it with, you know, hanging out with my dog and relaxing. I'm also going to try to edit new videos that I can post throughout the winter break. I've been working on quite a few longer videos, actually. And I want to sort of finish those up, too. I can't do pumpkin pie. I feel like pumpkin pie is a hit or a miss. I know people who love apple pie but hate pumpkin pie. I know people who love both. I know people who just like apple pie. I just repeated myself, but yeah. I think pumpkin pie is really... I love pumpkin pie, TBH. Thanksgiving is a tradition from celebrating the end of harvest. Well, of course we have the botanist here to explain the amazing harvesting itself, right? So it's more focused on fall harvest produce like squash and pumpkin, grains, bread, etc. Ooh, Boston cream is the best pie. Oh, I've actually never tried that. And yes, I love... Wait, low-key, Thanksgiving leftovers can be kind of fire. I just love turkey. I also have to say that my childhood home also has a really nice campfire. So Z's dad mentioned... What? Z's dad mentioned... Well, my dad likes to create like a little campfire where we could do s'mores. It's really nice. So I'm looking forward to going home. Pies aren't big where I live, so I've only tasted apple pie like twice in my life. What? Well, I think apple pie is pretty fire. In London, we have that giant Christmas trees. Wait. Yeah, no, I've heard about this, that the Norwegians send us for helping them during World War II. Ooh. Wait, but I do really love those. Oh, wow. I do really love those Christmas trees. I actually went to London around the same time last year as well, so I'm really excited to just go back. And I'll take pictures of the huge Christmas trees as well. Every year my dad makes some crazy pies. Really? All hail the meat pie. Savory pies. Wait. I've had like meat pies only a few times, and I feel like every time it's just poorly made. Maybe I just need to go to like New Zealand or somewhere that specializes in these, because I feel like I just haven't had a real one. McDonald's pocket apple pies. Wait, those aren't even authentic. And I feel like you can eat those in like 2 bites. It's not even a slice, it's like a rectangle. It's like a cursed shape. Chicken pot pie. Yeah, I was gonna say I've had chicken pot pie, but every time is not very epic. A Greg's sausage roll. Oh, also, hello, Syzygy. If you haven't already, go subscribe. She is a psychology science VTuber. Isn't that really epic? Chicken pot pies count as meat pies? Yeah, don't they? Wouldn't they? No? I have actually never tried this Greg sausage roll. So there's 2 things, or maybe even 3 things that I really like to eat in London. So Canoops, the hot chocolate, is definitely a must. There is a really good cookie store there. It's like Ben's Cookies. It's really fire. And then Fortnum and Mason, which sells amazing, amazing teas. I actually still have a canister from last year that I need to drink, but they last a long time. I really like getting this like sample pack where you can like try all these different teas. My favorite has to be like this smoked Earl Grey. I actually, so last time I went, it was really crowded during the Christmas time, but this time, I actually got this like special reservation for this like tea tasting experience. So I will send many pictures. It's really expensive, but I was just like, you know what? If I'm going to be there, I'm not going to be back for quite a long time. So we might as well, right? We have Bonfire Night, which is legally English Thanksgiving, but no one calls it that. It's about ritually what? Wait, isn't this also... I don't know if this is called Bonfire Night, but I know there's a celebration in the UK that, like, celebrates this guy who... I don't know if it was the UK or, like, Finland or something, who celebrates this guy who, like, almost killed a king but didn't succeed. It might be that. It might be that. I don't think it was called Bonfire Night, though. Maybe. Yes! Guy Fawkes Night! Yes, thank you, CLOFNIHBR. Yes, no, exactly. That's what it was called. Yeah, no, that was what I was remembering. Yeah. Guy Fawkes Night, yeah. Or Guy Fawkes Night? I don't know. Okay, so we're about to approach the hour. So I think we should actually get started. What do you guys think? Do you guys want to learn about op amps? Also, this was a huge hit on Reddit. I feel like people love the live lecture format, and I want to do a lot more of these. So yeah. Yeah, they're on the answer, also called Bonfire Night. Oh, they're also the same thing. Remember the 5th of November. Yeah. Also fireworks. It's cute that the British try and copy us. They don't have July 4th. We do good... Oh, maybe I should try a good meat pie in the UK. You guys are... I don't know if I have enough meals to cover all this food options, guys. Maybe I'll just have to stay another, like, year. No, I'm just joking. I really am excited for London, though. I find Guy Fawkes Night annoying because people set off fireworks late in the night. This gives me the same vibes as, like, July 4th, where they, like, I remember they, like, banned fireworks in LA. And people just set them off anyways. Well, I guess they did it first. It started in 1605. That is true. Well, one of my goals is to celebrate Guy Fawkes Night. Oh, frick, that's a lot of fireworks. A week before and a week after? That's crazy. Okay. I am so stoked to share this announcement with you guys that I feel like we have to get started. And I also feel like if you have any questions, if you have any comments, feedback, anything, let me know in Discord. And if you haven't already, go join the Discord. Or just let me know in the comments, in the chat, etc. I'm so stoked. What? July 24th, the whole month? That's crazy. In Edinburgh, they had police helicopters monitoring hotspots for fireworks. That's crazy. In LA, they had no monitoring. No monitoring whatsoever. Nuh-uh, not at all. Okay, how about we get started? Orbeez, what do you guys think? Are you guys ready to learn about op amps? Are you ready? Let me drink some water first. Slides will also be sent out in the description after the stream, and you can go through, click through the links, the photos, etc. LA's like 8 times the population of Edinburgh. Yep, that is totally true. Thinking cap is on. I got coffee, so hopefully won't fall asleep. Well, you will stay awake because I'm amped up for op amps. Alright. Let's get started on a beginner's guide to operational amplifiers, or op amps. So what is the goal of this presentation? Wow, there's 2 Z's on the screen right now. Crazy. The goal is to explore the functions and applications of operational amplifiers in electronics, and your job is to ask questions in chat. I really want to make this as accessible as possible. On Reddit, I know there were a few people who mentioned that they don't have electronics experience. Some people have seen this type of content before. Some people have worked with this extensively, and I know everybody comes from different backgrounds, so please be kind to each other in chat. Also, please just ask any questions that you have. This is a live lecture format, which is advantageous because I can answer questions as we go. And of course, be sure to stay for the huge announcement at the end. Also, this is a beginner's guide, which means that for those of you who may be more experienced with op amps, this might be easier for you. And that's totally alright. And if you see a question that you know the answer to, you can also answer it as well. I really want this to be like an open space to ask questions. Okay, that's all the logistics out of the way. Let's get started. Whoa, my clapping sound is like so intense today. Okay, so what is an op amp? So an op amp, or an operational amplifier, is a versatile electronic component that's used to amplify voltage signals. And it's represented here by this triangle. So there are 2 input terminals. There's inverting and non-inverting, which are represented by, well, the inverting is the negative sign and the non-inverting one is the positive sign. Another thing is that op amps need power to work. And so if you see on this diagram here, there's a V positive and a V negative. And that supplies power to the op amp for it to function. And I'll be chatting more about what exactly the inverting and non-inverting terminals mean. So op amps are really useful. They have a lot of applications other than just making voltage signals louder. They're used in signal processing, filtering, mathematical and logic operations. They're just overall really great. So one of the primary aspects of op amps is this concept known as gain, which is where you're able to amplify signals. And a really simple demonstration of this is you have the input that goes into the left, you have the gain, and then your output is much bigger. So in this case, if the gain is 10, the output would be 10 times the original voltage that went through at the input. And I'll be discussing more about the different amplifier types, but this is basically the ground foundation as to what drives op amps, this idea of gain. So what does an op amp look like? So some of you may have seen this before, some of you may have not. They sort of look like these weird, like, spidery boys. In general, the most common ones are these 411s and 741s. I believe the 411s are newer. And they have 8 legs, as shown here. But you can also get different op amps or more complex op amps with more legs. And the way that you use them is when you have a breadboard, you can put them across the breadboard columns as shown here. And these op amps, the 411 and 741, are good for general amplifier tasks. Alright, so let's start with the basics of op amps. So we need to start with the golden rules. So the 2 golden rules are inputs draw no current and outputs move to force difference at inputs to 0. So what exactly does this mean in English? Let's first start with inputs draw no current. So op amps have very high input impedance. that means that they draw very little current from the input signal source. It's like having a large resistor. It prevents from affecting the source of the input signal or loading down. So to sort of demonstrate this, let's say that inside this like gray box is your circuit that has a lot of current that's drawing into it. What we would see is that the input is like, I can't supply any more current. I'm struggling. And then the output of your circuit would have signal distortion, it would have power loss, etc. All these horrible effects. So the reason why op amps are so great is because it sort of protects us from doing this by accident. Op amps draw no current, which means that they don't have these loading down effects like signal distortion, etc. Okay, let me look at the questions in the chat. Where can you get op amp ICs that are not surface mounted for those who want to play with them? LM358 is available through Hole and has 2 op amps. Yeah, I can't think of names off the top of my head, but if Xenotime has it right, yeah. Chat, we got VTuber EE lectures before GTA 6. Yes, that's correct. EE lecture VTuber, let's go. Your local power station should have some if you're creative with the wrench. Well, there's actually, I mean, it's really easy to search for op amps. They're pretty much ubiquitous. You can easily find different types of op amps for your needs. Like I mentioned, there's like the 411, 741. There's ones that are better to use as comparators, which I'll talk about later, or different applications. Okay, next slide. So one example of how the first golden rule can be applied is in followers. So for a follower, a high impedance would protect the input, so there would be no current drawn. So what does this circuit do? So these lines represent wires. So there is a wire that's going in to the negative terminal, and then there's a wire that's looping out, and on the right side of the triangle is the output of the op amp. So there's a wire that's looping out from the input to the output. And then for the positive terminal, there is an arrow pointing down, which means that it's basically grounded. That means that it's like, we use that as our reference for 0 volts. And what we get from this is that V in is equal to V out. The reason for that is because that wire sort of helps us like determine that the input is equal to the output. So you might think like, oh, what's the difference between just having a wire here instead of using this crazy op amp circuit? Well, the answer is because of the first golden rule. Because there is no current drawn, a follower effectively protects our input and is really useful for cases where we don't want power distortion, where we don't want loss, etc. Signal distortion and power loss. So hello Phi, asks, is signal distortion and power loss different? So when I think of signal distortion, I think, so let's say we put a sine wave in. What we should expect is a sine wave out. Signal distortion happens when the sine wave experiences maybe some sort of exponential decay. It doesn't have that perfect rounded shape. It might start being a little shaky. There might be other oscillations. It might get really unstable, etc. Power loss is when we put in maybe a signal with 3 volts in, and we get a signal that is not 3 volts in and much less. So I hope that answers your question. The mnemonic I use when modeling these is that they make 2 nodes of the circuit that have the same voltage without sharing the current between the 2 points. Yeah. Yeah, if that analogy makes sense, yeah, that works great. Okay, so let's go on to the second golden rule. The outputs move to force the difference at inputs to 0. So that means that you remember the negative sign and the positive sign at the left side of the triangle? Well, at both of these inputs, the difference in voltage should be equal to 0. And this is useful in cases where we need a virtual ground, which creates feedback, which is basically the primary purpose of op amps. So let's go back to our follower example again. So that green arrow on the left represents Vin, so our input voltage. So initially, if the input voltage changes, there is a difference between the V positive and the voltage at the negative terminal. The op amp then amplifies this difference, but then the output changes so that it sort of rotates around this virtual ground. And so the process continues with this feedback until the difference of voltages at the negative and positive terminal is equal to 0. And this is called virtual ground because in this case, you see that the positive terminal is already grounded, which means that it's at 0 volts. And using the second golden rule, the voltage at that negative terminal must also then be 0 volts. And because of that requirement, that means that we can determine the voltage that is outputted by setting both of these terminals to 0 volts and being like, okay, what output voltage would we expect given this? So another reason why this second golden rule is so important is I sort of hinted to it in how the follower works. The op amp basically amplifies a difference between the voltages in the terminals until they're equal. And this is the foundation for the most important use of op amps, which is this idea of negative feedback. So to sort of describe what negative feedback is, imagine your house has a thermostat and your room gets way too warm. The thermostat would then detect this and turn on the air conditioning, and so the room cools down to the desired temperature. This is very similar to what we're doing in op amps. When the voltage between the terminals is different, the op amp sort of detects that and then basically forces the voltage inputs at 0 so that the room or the output circuit reaches an equilibrium point that we desire. So does it matter whether we use the positive or negative terminal connected to the ground here? Yes. And the reason for that, and I'll go into more detail later, is that that negative sign is actually representative of negative feedback. So if you want negative feedback, we need to use the negative terminal. So you can see that the positive terminal is just connected to ground, but all of the craziness, like the wire that's going around, is connected to the negative terminal. And that's an indicator that we're using negative feedback to drive this op amp. So I guess a better way to sort of describe this is with a more complex circuit. So the benefits of using negative feedback is that for an op amp, it makes the gain or the amplification on external components rather than the op amp's internal characteristics, and it reduces the distortion, which makes the output a more accurate representation of the input. There's noise reduction, and etc. So let's sort of walk through this circuit here. So like what's going on here? So this looks very similar to the follower we had before, but now we have R1 and R2. That represents the resistors. So we're actually putting resistors into this op amp as well. So the part of the output is fed back to the negative sign, the inverting input. So if you trace from the left-hand side, VE represents the input, and it sort of moves into the op amp. But then you notice that there's a wire that's going around to the right side, which represents the output. That means a part of the output is being fed back into the inverting input. This signal is then subtracted from the input signal. The op amp then follows the second golden rule, which states that it amplifies the difference between the inputs. And it keeps amplifying until the inputs are almost equal. So the big part is that wire that stretches from the output back to the input. That's what drives the negative feedback. So let's look at some more examples of negative feedback. So here is an example of the inverting amplifier, which takes an input signal, which I've sort of doodled there on the left as a small sine wave, and it does two things. It amplifies the signal, as in it makes it bigger, and it inverts the signal, which flips it upside down. So the input signal goes into that negative sign, that inverting input of the op amp. The output of the op amp on the right side is connected back to its input through a resistor. And this is called feedback, and it can control how much the signal is amplified. So when we put in that tiny signal there, what we get out is an inverted signal. So you can see that now this output signal, instead of going up first, it goes down first, and it's much larger than it was before. And then we can actually calculate how much it's amplified by the ratio of the resistors in the op amp. So that G letter represents gain, and it can be calculated by negative R2 over R1. And by choosing these resistors, you can make the output signal bigger or smaller than the input. So let's say that you have a resistor, second resistor of 100 ohms, and you have a first resistor of 1 ohm, then your gain would be negative 100. You would see a signal that's 100 times larger, but flipped upside down. I'm glad to see all the excitement in the chat as well for the op amps. Just in time for my water break. Okay, so that was the inverting amplifier. So let's actually work through a few examples. What is the gain of this circuit? So you can see that there's 47 k ohms. So that k ohms actually represents kilo ohms. So that is actually 47,000 ohms. And on the left side is a 100k resistor, or 100,000 ohms. To calculate this, we use the same equation as we did before. We have that second resistor that's going across, that's causing the feedback. So that's negative 47k over 100k, which gives us negative 0.47. So if the input signal has an amplitude of 1 volt, then the output signal's amplitude would then be negative 0.47 volts. It would be reversed, and it would be smaller or attenuated. Yeah, also, please keep in mind that the symbols can actually vary. For instance, ground can be represented by this horizontal line. It can be represented by an arrow. There are many different conventions. I think I'm probably using more of a US school convention, but I know in Germany they use different symbols for ground, like a pitchfork symbol as well. So yeah. Okay, next example. So that was pretty straightforward. So let's do it again. What's the gain here? We know that second resistor stretching across is 220k, and that first resistor is 100k, which means our gain is negative 220k over 100k, which is negative 2.2. So if we were to put in a signal with 1 volt, then our output signal would be 2.2 volts, but reversed, so inverted. And that amplifies the signal. So inverting amplifiers can both decrease and increase the signal. Which means it's time for us to introduce our next circuit, the non-inverting amplifier. So here, the inverting signal is applied to the inverting terminal. So we see this like signal that's going in here through the left. Wait, no. The input signal is going into the non-inverting terminal, which is the positive terminal. But as you may notice, all the crazy circuitry is happening after the negative terminal. And that's because all of these amplifiers require us to use negative feedback. So you shouldn't see a case where a non-inverting or inverting amplifier uses that positive terminal with the resistors. It always uses the negative. The thing about a non-inverting amplifier, though, is that its minimum gain is 1. You can't attenuate or decrease a signal. So therefore, an inverting op amp is good if you want to sum signals, if you want to do current to voltage conversion. This one's better for buffering, voltage amplification, etc. So let's sort of walk through this. let's say you put in a tiny sine wave. What you should get out is the same phase of the sine wave, but much larger. So you can see that the sine wave first goes up and then down. Similarly, the output signal goes up, then down. And the gain here is calculated by 1 plus R2 over R1. And please, please, please remember the 1. There have been so many cases where people have forgotten the 1 and it causes some sort of issue, especially when you're working with low gains. Ground is a flat line because the Earth is... No! No! I do not approve that message. I see this chat uses different flat jokes than other VTuber chats I've seen. You can think of it forcing a V in voltage drop or the... Yeah, I've seen a lot of ways to describe this. I've also seen this as being like, you're sort of like rotating about the negative feedback. So a lot of different ways to visualize this. VE voltage drop over R1. Yes, so using the first golden rule, we know that the positive terminal... I don't know if there's a way to do... Yeah. So the oh, yeah, this is really nice. So the positive terminal here should be VE. And then this negative terminal should then be VE, which then goes down here. Okay. So let's work through an example. What is the gain? We basically use... Oh. What? There's a dot. Oh no. Let me erase the dot. Oh, okay. What is the... Oh, this was the laser pointer. Sorry, guys. The S in Syzygy stands for scuffed. What is the gain? So, we again use the same equations as we did before. 1 plus R2 over R1. Where in this case, R2 is the resistor that's across, which is 220K. And then R1 is the resistor going down, which is 100K. So we have 1 plus 220K over 100K, which is 3.2. So if we have a signal with an amplitude of 1 volt, then the output would then be 3.2 volts. And again, for these non-inverting amplifiers, you can only increase the voltage. You can only have a gain that's greater than 1. Earth is actually cat-shaped. I can't believe chat is talking about the shape of the Earth, one of the greatest mysteries of all time. Oh, the formula for the gain. Oh, that must have been crazy. I don't even know where to even start with that. I've never personally derived the formula for the gain. Getting gains, yep. So let's look at some interesting applications of negative feedback. For instance, you can do this thing called a voltage summer. So you put in V1, V2, V3, all the way up to Vn, and your output signal would then be the sum of all of them. The multiple inputs would basically sum to become one output. And the really cool part about this is that each input can contribute differently to the final result, and it's really useful if you want to combine multiple signals in like audio mixers or sensor systems. And this uses that negative feedback we talked about. You can see that the resistor is sort of stretching over from this negative terminal. Here's another example. Let's create an electronic voting system. So let's say each person submits 1 vote, and a bill is passed when 5 out of the 9 people vote in favor. How would you design this circuit? Well, you would design it using a voltage summer. So you have each of the different rails representing a different person. And instead of comparing it to ground here, you compare it to 5/9 volts, which represents when 5 out of the 5/9 of the input voltage, I guess. Which then represents when 5 out of the 9 people would vote in favor. And the really cool part about this is, let's say we have maybe like the president who's also voting, and we want one person whose vote matters more than the others. How would we do that? Well, we can actually adjust the ratios of the resistors. So to give one vote more influence, we should use a smaller resistor for that input. And so the smaller the resistor, the more weight or the more voltage that the vote carries. That's because the input current is determined by the voltage over the resistance. So a smaller resistor would mean a greater current. Yeah. All right, let me quickly read through chat. Are you going to be covering signal processing math in the future? I actually really want to do a video on that. I know one of the first videos that people kind of stumble upon on my channel was the one about pulse compression. I really want to do a series on that, so maybe I should make a lecture series. Who knows? I'll jot that down. Maybe that's the type of video that you guys want to see when I'm on break. Z should know the shape of the Earth being from space. Exactly. Yeah, no, I know that the Earth is flat. No. The Earth is not flat, guys. Orbeez, the Earth is round. Can explain circuit components like a boss, but couldn't find the laser pointer. Yep, sounds about right. Let's smoke out. Hi, hello. Signal processing math would be great. Okay, I'm happy to do a video series on that. Let me know what kind of videos you guys want to see, because I need to start cooking them before break starts. I assume this background knowledge. Oh yeah, I guess I should have mentioned Kirchhoff voltage and current laws. It would be great to sort of be aware of that. But I also hope that this can be sort of accessible just in terms of like knowing what inputs go where and how does the weird triangle circuit work. Okay, next up is the differential amplifier. I'm having way too much fun with this laser pointer. What does this do? Okay, what it does is that it actually amplifies the difference between the two voltages. So imagine you're trying to hear your friend whisper in a noisy room. What you're actually doing is that your brain is focusing on the difference between your friend's voice and the background noise. And a differential amplifier basically does this electronically, so you can pick out those important signals from the noisy environment by amplifying the difference between the voltages. And it's really good at rejecting common noise, and it's widely used for clean signal processing. So just to add on, these two are basically just like an additional little thing, a little bit more advanced for those of you who are not familiar with these. Another important circuit is like an integrator. It's made up of a resistor and a capacitor here. You can sort of think of it like a bathtub that's like filling with water. So the input signal is like the water that's flowing in from the faucet, and the output is like the water level in the tub. So if there's a constant input, it makes the output rise steadily. So the water level would like increase. That represents like the voltage. If the input changes, the output changes its rate of increase or decrease. So in this case, let's say we have a constant rate. We would then see, well, I guess if you assume this is 0, the center is 0, and this is negative, that means that our output would be decreasing. It corresponds with a negative slope. On the other hand, if we have a positive value that's being inputted, we would experience a positive slope. It sort of adds up the input over time, which is this idea of like integration or being an integrator. So the key points is that it sort of accumulates the input signal over time, and it's useful for turning these like sudden changes into more smoother transitions. And for instance, it can turn a square wave into a triangle wave. Similarly, there is a differentiator which basically finds a slope. So the slope here is negative, we would get a negative value. Slope here is positive, we would get a positive value. And these do that because they're dependent on this capacitor, which basically charges and discharges as the circuit continues. All right, let me quickly... So the next part is positive feedback. Before we get started, let's quickly read the chat. You're explaining this better than my professor did. Oh my god. Well, thank you so much for the kind words. I hope that this is coming off as quite accessible. Hello, Box Cat. Sorry you can't stay very long. Well, goodbye, Box Cat. Are you a cat, perhaps? I do love laser pointers. I'm actually more of a dog person. Earth is round. Is toroidal. Yes. Is a differential amplifier what sits at the end of balanced input signal wires? Maybe. Maybe. I'm actually not sure. If someone in chat knows, please answer. The differential one is like the normal one, but relative to a second input. Yes, exactly. Instead of being relative to ground, so it basically looks at the difference between the voltages. Yeah, I'm glad this is clicking. Yeah. Are we going to see a circuit using inductors? That's a little bit advanced. There are ways to play with. I mean, I could do a video on like RC, RLC circuits. But I feel like here I want to make this accessible, and so if I were to use inductors, I could do a whole other live lecture on like how RC circuits work, which is a whole other bucket of worms. It involves things like high pass filters and low pass filters, where you can detect like higher frequency or lower frequency signals. So that would be probably saved for another live lecture. Okay, so all these circuits were with op-amps negative feedback. So we can actually use the positive terminal too, but not as often as we do the negative terminal. So how does positive feedback work? So an example of this is the Schmidt trigger or a comparator. Basically a tiny change in the input signal is detected by the op-amp, and positive feedback means that instead of trying to bring it down to equilibrium, it sort of increases the oscillations even more. So if there is like a tiny oscillation, it makes the oscillations like more intense. It takes a small input and sort of like makes it grow rapidly until it reaches its limit. So for instance here, you see now we're using this positive terminal. That's really important because it creates a reinforcing cycle. It makes the output larger and larger and larger here. So when an input signal goes above the higher trigger point, the Schmidt trigger basically switches to on or high. So let's say you put in this like really wacky signal here with centered at 0. What the Schmidt trigger does is that it basically saturates it to its like upper and lower limit. And you get something like this. So here it's positive, it's above the threshold. Then we would get a positive signal. On the other hand, if we have a negative signal here, we would just get straight negative. So it basically goes high and low. So the output stays on until the input signal drops like below the trigger point, then it switches to off or low. So it's high and low when it's above or below the threshold. So it actually cleans the output. It can turn like really wobbly, messy signals like these into crisp and clear digital pulses by basically saturating the output. I like the inclusion of different symbols here. Yeah, I will be sending out the slides later, and these pictures actually come from different sources. And that's also to demonstrate that you might be seeing a different symbol. Like for instance, this is also representative of ground. It sort of looks like that arrow pointing down. With an ideal op-amp, would this destroy the universe? Well, no, because one other thing to sort of mention is op-amps can have a signal limit. When I said at the very start, op-amps require power. And that sort of sets a limit. So let's say that you put in positive 15 volts at the positive sort of like, it's usually drawn here. So if you put positive 15 volts here, negative 15 volts here, the op-amp will never go above that point. So the dependence on how amplified we can go, to answer Matt's question as well, is to basically set the limits given by these rails. So you would connect another wire here to a positive 15 volt and another wire here to a negative 15 volts. Yes, Marlin's correct. The V positive, V negative voltages are what the signal would get saturated to. So if you have a really extreme signal, it would never go above 15 or negative 15 volts. And in that case, you would say the op-amp is saturated. Now that's good in some cases where you want to protect the following circuit, but in some instances, saturation can also cause like weird like oscillatory effects, especially when it comes to positive feedback, which is why it's important to make sure how saturated you are and if that's really what's necessary for your project. So that was basically a rundown of positive feedback, and I guess I sort of wanted to wrap up this presentation by saying that op-amps are really powerful components, and the easiest way to learn is to actually get hands-on and build them. So this is actually a circuit that I built, I think a few weeks ago as part of a demonstration. I know the wires are a little crazy. I could have definitely been a lot more efficient with that. And what this has are a lot of cool components like an LED bulb. It has a capacitor, and this is the op-amp here at the center. And you can actually see these wires that are stretching across to this negative rail, to this positive rail. And you can look at, if you search the word pin out, you can actually see like which pins to use for the different components of this diagram. So if the negative terminal, I believe, is the second dot. So if it kind of goes like 1, 2, 3, 4, and it goes around. Oh, we got 1, 2, 3, 4, 5, 6, 7, 8, like back up. So like in sort of a U-shaped motion. And you can connect wires. You can also have like the positive one, I think is 3. It's really easy to just search this on Google. Breadboards rule. Yes, I love all the breadboard enthusiasm. I've seen way crazier. Yeah, no, this was a simple demonstration. It was actually just building this circuit here to the right, which is a, I actually don't know how to pronounce this, a wine bridge oscillator. What it does is that there's no like power source. The only power source is what's driving the op-amp, but it has an LED bulb, and it just kind of just sits there. And what it does is it creates this really nice sine wave from the circuit. So this is just a demonstration of one of the kind of things that you can build. In fact, students usually tend to start on like building a basic like non-inverting amplifier and an inverting amplifier, and sort of playing around with that first. So does anyone have a resource for reasonably priced oscilloscopes? Well, I have to say, if you're part of an institution, usually they have an electronics lab or a physics lab that should be pretty well accessible. Like for instance, like this proto board here, this oscilloscope here, were all parts of this physics lab that I'm part of. So yeah, we want a breadboard in my class. Oh man, I want one for myself. I feel like breadboards are so much fun to play with. And I know this might be a bit of a stretch too, but if you ever want to get even more hands-on with circuits, playing with Arduinos and Raspberry Pis is also an amazing experience. Home Depot has some small ones. Oh, yes, please send the resources. Also, yes, Matt, I think I might need a stream where I just play with a laser pointer. This is a lot of fun. I actually have an incredibly like powerful, almost like military grade laser that I use for stargazing nights when I volunteer for stargazing nights, and it's really easy to point to things in the night sky. I'll try to take a picture the next time I use it. I've heard of digital oscilloscope tools. What? Designing your own PCBs. Ooh, yes, no. That one is much more advanced, but it's a lot of fun. So, I guess to sort of wrap things up, like, op-amps should not be scary, because you can easily take a crazy circuit like this, representing an electrocardiogram, and actually just break it down into its individual components. Oh, I don't know if I fully did this right. Okay, I don't know if I fully did this right, but I guess this is a demonstration of how to play with a circuit. So you have an input here. These are actually diodes and they protect the input. But you can see, like, if you look at these individually, these are basically, this is probably more like a differential amplifier. These are basically different parts of the circuit that represent these components that we've learned. And a big part of electrocardiogram is that it's dependent on amplifying a signal. It takes like a small like electrical signal from like your heart or something, and it amplifies it so that it's easily readable and detectable on a screen. Another example is that you can build circuits yourselves using basic components. So here's an example of a lock-in amplifier that costs $9,100. What a lock-in amplifier does is that it can find and measure these like tiny signals hidden in a heck ton of noise. So you basically see the signal, it's basically all noise, but you know that there's an oscillatory signal hidden within it. And how it works is that it takes a clean reference signal at the same frequency and multiplies that noisy input by the clean reference signal. Here's a diagram to actually show that. And it sort of filters it out, and then the output is actually just a straight line, a DC signal that represents the strength and the phase of that tiny signal you were looking for. Now this costs $9,100, but you can actually build these components yourself. You would have to probably do some Googling, but like an idea like an amplifier, we've talked about that even within the first like hour of this lecture. And of course, it won't be as good as this $9,100 lock-in amplifier, but it demonstrates that it's not just a black box where these signals exist, but something that's actually breakdownable and easy to make. Exactly, it's over 9,000, it's crazy. Let me quickly read through chat. Software oscilloscope. Ooh. Yeah, no, if there are great resources for that, please let me know. Too many Raspberry Pis. Raspberry Pis are a lot of fun to play with. I am not a cat. I'm actually more dog-like. Dream Source Lab. I'll actually include this link into the description too and see. Yeah, no. PCBs are great. You can use USB connected probes. Whoa, I actually did not know that. That's probably a lot easier to use for those of you who don't have access to a lab or an oscilloscope. Ham radio. Yeah, one thing that you can build with like an Arduino, by the way, is you can easily send signals back and forth. Yeah, and potentiometers can let you change the gains. So for those of you who don't know, a potentiometer is like a variable resistor. Basically, you can turn this dial and you can increase the resistance, and you know the equation for the gain has the resistance in it. No, don't build your own nuclear reactor. Yeah, no, like if you see a diagram like this, it's really easy to get like overwhelmed and see what's going on, but it's really easy to sort of break it down into these block diagrams. And so, yeah, that's basically the basics of op amps. So just to summarize, I hope you've learned something new. I hope this was very beginner friendly for those of you who are new to electronics, and exciting for those of you who are more familiar. So yeah, woohoo! Lecture is complete. Woohoo! I hope you guys enjoyed that. I actually had so much fun making this presentation as well. I've also been sort of playing around in the lab and playing around with electronics. I accidentally blew a capacitor a few days ago in front of an audience, which was really embarrassing, but it's also a lot of fun. But it also shows like we're all beginners here. We're all learning. Detect Z with microwave detector and cat treats. This was incredibly helpful. Thank you so much. Woohoo! Thank you guys so much. I'm glad you guys really enjoyed that, and I want to do more things like these. Maybe I'll make more presentations, so when I'm back, I can do like 30 live lectures. So if you guys have any questions, let me know. And, okay, let's say at the 45, so in like a minute, let's do the huge announcement. I am so stoked. Woohoo. My PI blew up 2 Arduinos in one day. Honestly, my so one of the TAs that I was working with, who's like sort of manages this lab, like he's been doing this for a really long time, and he was demonstrating a circuit. He blew the proto board. So there's these thing called protoboards. It's like a breadboard and like a power system. He blew the fuse on the protoboard, but he didn't know what the issue was. So he was like, you know what, let's try it again. Blew the fuse on the second protoboard. And it was so funny because we had like this like this train of like protoboard corpses. But fortunately the protoboard fuses were really easy to replace. You basically open the back and you like take out this little thing, and if the fuse is blown, there's like a little bit of like dark smoke, and you can like put it in. Thank you guys so much. Huge announcement time. Yes, huge announcement time. Do I get attendance points? Yes, you do, because you're here for the huge announcement. Here, let's do the loading screen actually. Can we get a math rule in Discord? Ooh, baby, maybe so. Yeah, no, fuses are really easy to replace though, so it wasn't too big of a deal, but it was really fun. Would love to see how you mess around and do experiments. Honestly, I'd love to do like a live stream where I just solder something. The issue though is that the labs that I use are basically public spaces, and so I don't know, maybe you'll walk into your lab and be like, who's this individual here who's live streaming? Who's this individual who's live streaming while soldering? That will be me. No, popping capacitors are a little scary, and they also smell nasty. Did I miss content for the op-amp exam? Well, the VOD will be up, so don't worry. Do you have a helmet? I mean, I usually like to use safety glasses, especially when I'm dealing with larger capacitors. Yeah, exactly. Like, I want to film in my university's like lab / makerspace, but people don't know I'm a VTuber in real life, and I feel like that would be a lot of explanation to do. Maybe if I have some time like off hours and if I can get like late night access, maybe. It's not really a public lab, I guess. What I sort of mean is like it's sort of like part of my institution, which means it's like accessible to students. But of course there's like regulations, like for safety reasons it's best to have like more than one person in a lab, and etc. Oh yeah, no, fume hoods would probably be really nice. The issue is that the fume hood in the lab I'm using is like full of junk. They've just used it as storage space, and apparently it doesn't even work. Yeah, no, honestly, maybe I honestly think having an anime girl explain things just makes things 10 times easier, right? Yeah, it's a shared space. It's not necessarily public. Yeah, that's exactly right. Okay, it's 9:47, which means it's time for the announcement. Are you guys ready? Drum roll, please. So, a few days ago, I released this mysterious trailer. What could this be? What could this be? Are you guys excited? I kid you not, I have been like waiting so long to tell you guys. This has been something that I've been so excited about, and I'm a total blabbermouth. Like when I hear something, I want to say it right away. And so keeping this to myself has been so challenging, and I really am so stoked. What could this be? Okay guys, you guys have to do drum rolls even louder. Otherwise this image won't load. This image is dependent on how much drum rolls you do. Double dabbing. What could this be? What could this be? Who was the individual on the left? Who was the individual on the right? More drum rolls. More drum rolls. I better be hearing like earthquakes or something, because I better be hearing all the drum rolls all around the world. The world better be like dented by these drum rolls. All right. It's a little bit brighter. All right. What could this be? What could this be? Oh my god, so many drum rolls in the chat. Oh, even the special banjo drum roll. What could this be? Drum roll, please. Shatteringly loud drum rolls. Drum roll. Oh frick, I knocked over my microphone. Drum roll, please. Okay. I am so thrilled to announce I'm part of VTHEOREM Gen 1.5. And I will be joining VTHEOREM Gen 1.5 with the amazing Myelin Ekamon. I don't know if I said that right, but oh my god. Oh my god. I have been so excited to tell you guys. And I know some of you guys were even mentioning that, like, you know, Z should join VTHEOREM. You know what would be really great if Z joined VTHEOREM? Let's freaking go. I know, I'm such a nerd. And for those of you who don't know, VTHEOREM is basically an indie group of amazing science education VTubers. And it's really a place that I've been looking for, you know? Like, as a science VTuber myself, I have been just so excited to just be a part of this, like, amazing group of, like, science enthusiasts and communicators. Oh my god, thank you, Penboozle. Oh my god, thank you guys so much. I'm so glad that you guys are really stoked. And I just wanted to feature some of the art that's come out of this. You know, we've been really working on this for a really long time. This artwork was actually created by Myelin herself. And, like, absolutely crazy. Absolutely crazy talent. So you'll be seeing a lot more artwork from us. I know, isn't it amazing? There's actually, like a psi symbol in here. Because Myelin does psychology content, and there's like a black hole in like my eyes. Isn't that so gorgeous? Yes, I'm so glad that you guys are also really excited. A physics VTuber in a science group never could happen. Never could happen. But I feel like also, this is just a great way to just centralize all the science VTubers, and at the end of the day, like, this VTuber group has also just been an amazing group of friends, amazing group of supporters. So, I guess that was a formal announcement. What I sort of mean to say is, holy moly, holy frick. We're in VTHEOREM. I'm part of a group. What? This was like my actual reaction. So, I guess just to recap, like, when I first got into VTHEOREM, I was just chilling. I was like, I was just opening my email. And I opened my email and they're like, well, I of course had to apply and audition and interview and so forth. And then I open up my email and it's like, we are pleased to announce, or like, it was like, congratulations. I was like, holy frick. I literally leapt up from my chair. I started like dancing. And I was just so overjoyed. I'm back. What did I miss? The craziest announcement probably of my VTubing career so far. Woohoo! I searched VTHEOREM and I get a bunch. Yeah, so I'll chat a little bit more about like what VTHEOREM is and how you guys can like follow things. But I just wanted to say, holy frick, we're in VTHEOREM, guys. We're in VTHEOREM. We're in a group. Oh my god. Oh my god. Okay. So, what is VTHEOREM? If you haven't already, go to X, Twitter. I don't know if VTHEOREM has a blue sky yet, but go follow. Go follow. It's a group of STEM VTubers. So on the left here is Gen 1, which includes Syzygy, Phi, and Nep. I'll sort of give a brief description of them coming up next. They were the original Gen 1 from like a few months ago, several months ago, I think. And they all produce amazing science content. And yeah, no, I just, you know, when I first started VTubing, like, VTHEOREM was one of the first groups that I encountered. And I was like, you know what? This is the dream. It's my dream to be part of a group that really represents like what my goal is as a VTuber, which is to promote science education, to battle misinformation, to basically share about science in a really accessible way. And thank you so much, Something Stochastic. Thank you so much, Podcast Senpai. Thank you, everybody. And so I have been really excited to announce this. Not because it means changes to my channel, but also because it has a lot of deep significance to me as well. So a little bit about everybody. So getting to know Gen 1, right? Go follow them right now or you'll be small brain. I wonder if there's a way to sort of make this a little bit bigger so that you can just like see their channel names. So on the left is Phi, the Neutrophil. He doesn't actually look like an Among Us. I just use like funny emojis. Phi does like content on like biology, on immune system, type stuff, about cell biology, etc. Actually, we've been sort of planning a collab, wink wink, which I will chat more about later. Syzygy does psychology content. Okay, so Phi is primarily on YouTube. Syzygy does psychology content primarily on Twitch. And I think she recently released like a video on like different papers, like journal club type stuff. It's super cool. Go follow. Yes, and thank you so much, Pambu, for dropping the links as well. And then there's Nep, on the very right, who does like, I feel like a good mixture of like botany content. So she focuses a lot on botany, but also just like art and fun content as well. Thank you so much for dropping the links. Yeah, no. The Folds the experience. Yeah, no, I am dancing in happiness. Sai recommended my channel. Yeah, no. Honestly, one of the reasons why I really just love this community is because you can see on the bottom, they've been the best senpais, I mean mentors, in my VTubing journey. They've sort of taught me the ropes about like how to get started, how to best communicate science, how to not get copy striked, all these basic things that don't really come easy as a starting VTuber. Yeah, no, thank you so much for dropping the links, Pembu. And so, sort of, what have we been working on behind the scenes? So, Myelin does amazing art. I think if you could also link Myelin's channel as well, that would be amazing as well. I actually realized I never included a slide for Myelin's channel, but Myelin does psychology content. You should also go follow her on X as well. But Myelin is also an amazing artist. So this was the original like draft design for the dabbing like teaser we were going to do. And then like I was having a rough day and then I opened Discord and Myelin drew this amazing adorable art of me on the back of this like random psychology paper, which I feel like just encapsulates our energy so well. And of course, like, yeah, here, let me also sort of paste this. So this is Myelin's channel. And so there's gonna be a lot more artwork for us. And I feel like this is something that I feel like I've never, like, you know, just free art. And also, like, Myelin is just so amazingly talented and just so passionate about psychology and all these things. We've been chatting, like, on our little, like, VTheorem Discord about anything from, like, broken elevators to, I guess, like, the election and to, like, how to best, like, share presentations and giving feedback on each other's work and so forth. It's just overall just an amazing experience. So with this crazy announcement may also come some frequently asked questions. And so I just wanted to sort of navigate with you guys what this will look like. So what's going to happen to my channel? I'm graduating. No, I'm just joking. Okay, I actually should not joke about that kind of stuff, but I'm not graduating. I'm not getting rid of this channel. I'm not going to another channel. Everything will stay the same. I'm still posting live streams. No, don't scare us. I promise you, I'm not graduating. Everything will stay the same. I'm still planning to post live streams, do videos, but just with a little bit more support from friends, which I feel like is just net positive. So then you might ask, how exactly does VTheorem work? It is a little bit different from a typical VTuber group. It will be sort of a centralized network for people who are seeking science VTubing content, but it isn't an agency. So it's very different from sort of like the bigger like VTubing agencies or VTubing groups that you see out there. It's rather just a band of indies who are really enthusiastic about science. Yes, oh, thank you, Phi. Thank you so much for joining. Go subscribe to Phi. And thank you so much for your support. So stoked for all the collabs and streams ahead. Yeah, same old Z is best Z, exactly. It just means that I'll be getting a little bit more feedback, support, and just enthusiasm about science from a broader science community. And since it isn't an agency, it also means that I just have like a lot more creative freedom. So basically everything will stay the same. I will post whatever the heck I want, just with a little bit more support. Yeah, network and combine talents, exactly. So, what kind of V-Theorem content will I do? Well, this is actually a question that's more directed to you guys, because I want to make sure that you guys also have amazing ideas, and we have basically infinite time. So let's try to brainstorm ideas together. But so far, we've thought of, like, we're gonna maybe do a V-Theorem 1.5 debut with Myelin, which may include some more canonical lore, by the way. Yeah. And that will probably be after my winter break, so that Myelin has a bit of time to also prepare amazing, gorgeous art for the debut. This will be a huge event. I also really want to showcase Myelin's channel, who does also amazing content. It may also include group collabs and art. Things like trivia, interdisciplinary explainers, doing journal clubs across fields, which is something that I've always wanted to do, and also more amazing art. And also it means that we might get featured as a group on podcasts, on Reddit, on other platforms, etc. And of course, any ideas that you guys might have, that you guys want to see, let me know in the feedback channel on the Discord or in the comments of this stream as well. Yeah, exactly. It's like so this is basically like a VTuber Science Alliance. Science Alliance. That rhymes. Design a CubeSat concept for each V-Theorem member. Launch a CubeSat for each V-Theorem member. What? VTubers in space? What? Well, one thing that I have been working on is I'll take a picture of this later. I've actually 3D printed the V-Theorem logo. So I spent some time designing in CAD, and I printed the V-Theorem logo. Just some of your rants and like TED Talks? Yeah, no, I would love to do like a live lecture with friends. So you might be wondering, when? Like, what's going on? Like, what is this long winter hiatus, etc. So there are 2 live stream breaks that I just kind of wanted to focus on. So I'm gonna bring on the laser pointer again. So this is today. Oh, frick. I made this slide on the 19th. So this is today. This is today. So I'll be gone for about 8 days or so. 9 days or so. For Thanksgiving. I'll be back for like 1.5 weeks, but it might be a little crazy, so I might only do like 1 or 2 streams depending on how my schedule works out. And then the long winter. So I guess what I mean to say is that the next few months will be a little bit crazy just because of all the holidays and all the traveling, but don't worry, I have quite a few videos that are actually planned to be released over the long winter, and I'll be replying to comments. I'll still be posting images. If anything, I'll have more time to post images. I just won't be able to do a live stream. It's very similar to the live stream break that I did when I went to Japan, where I just didn't stream, but I kept posting videos. Winter is coming. Yeah, no, exactly. So this will be quite a bit, but then when the new year starts, I'll be doing a lot of exciting content. Although it makes me a little bit sad. I really wanted to celebrate Christmas with you guys, but at the same time, like, I'm also glad to be back home, to rejuvenate, to travel. And I'm sure when I come back, we'll be doing a lot of exciting V-Theorem content that we'll be planning for over the winter break. So, until then, thank you guys so much for your support. I know these breaks can be, like, quite long. But I promise you, I'm not going anywhere. I'm not disappearing. I'm still going to be me, and I'll be back in live streaming as ever. But I'll just be having an amazing time at home. Yeah, the Cosmic Microwave background is always with you. And I'll still be posting videos. In fact, I actually have a few videos that I'm planning to post in the winter. I know I sort of hinted at some of these, like in the Discord. Maybe a video on ITAR. I don't know if you can hear that. On ITAR. On space policy. Yeah. So, hopefully, you guys will be able to see that content. And so this is basically the last slide. I just wanted to say thank you guys so much. Honestly, joining VTheorem, being a part of this amazing community, it wouldn't have been possible without all of your guys' support. And I really, please also show VTheorem all the love and support. I really think they have a really great mission, and I'm just so excited to be part of that. So yeah, I must survive my physics finals without her guidance. I promise you, when I come back, I'll have amazing ideas. I also think that this will be a perfect time for me to like build more content. and plan more content so that I can maybe do content more often. Join the Discord to stay in touch with everyone. Yes. ITAR content. Yes. Lost in her eyes. No simping. No simping. Well, I do simp for this artwork though, definitely. Yeah, and maybe a lot more streams. Maybe even a series on pulse compression. Who knows? I'll try to see what I can cook up. And yeah, I've been so excited to share this news with everyone, and I'm really excited for this new era ahead. And I'm so excited to join this group. So yeah, that was the big announcement. I'm really glad you guys enjoyed. Okay, so I think what we could do next is just chat for a bit about a few things. So, I'm leaving tomorrow, actually. So this feels like really weird, because it's like not only my last stream, but it's also like I'm gonna be leaving and traveling starting tomorrow, so I'm really excited. So I'm curious, what will you guys be up to over the Thanksgiving break? Anything fun? Or I guess for those of you who are in Europe, maybe you guys aren't doing any celebrations. I'm leaving. No, I promise you I'm not graduating. I'm still traumatized from Ame graduating, so I promise you I'm not graduating. The job hunt continues. Yep. Grinding leak code continues. Yep. Same old, same old. I want to do a stream where we do puzzles together. I've also been playing around with this website called Kaggle, where you can build like ML models. I actually like found out about this website like a year ago, but I heard that they have like competitions where you can play around with like different features. So I was like, you know what, might as well. And it's actually been so much fun. It's been a lot of instruction. I know it's a little bit different, and I want to self-learn it and then maybe do a stream where we do like build a Kaggle machine learning model. I don't really know how it works just yet, but I'll keep you updated. Oh, the Natural History Museum. Yes, I actually visited that last time I went. That was really, really fire. I really love the Natural History Museum. Working job, the free time and job. Learning Japanese. Ooh, I actually heard that for English speakers, so the military releases like a list of languages every year, and it sort of like ranks like how difficult each of the languages are. And Japanese is one of the hardest languages to learn for English speakers because the grammar structure is different. It requires like knowledge of Chinese characters, like the pronunciation is very different. So it's actually really high up there. I think it's up there with like Arabic and like Chinese and stuff like that. So yeah. I think learning Japanese would be really cool. I also really want to be more fluent in like Morse code. I do know Morse code letters, but I want to like become so fast that I can be like beep 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 beep, and then like be able to like communicate a message, you know? Another thing that I'm planning to do, so I'm going to Europe, right? So I'm going to London, and then I'm also going to Paris, which is going to be so much fun because I've actually never been to Paris. You know, just doing all the touristy things like Eiffel Towers, eating a lot of croissants, etc. So I'm really, really excited. If you guys have any recommendations for that, please let me know. I was actually, one of the mods for the VTHEOREM Discord, and I guess, like, Syzygy is, like, also, like, yeah, I think one of the mods for the VTHEOREM Discord, is in the UK. So I was also trying to like meet up, but unfortunately like we were missing each other by a day, which was so sad. I feel like a live, like, what's it called, an off collab would be so fun. I feel like I definitely want to do an off collab. That's like one of my goals as a VTuber, to do a really fun off collab. Yeah, kanji is definitely the hardest part to grasp. Yeah, no, yeah. It's like also a lot of memorization, because you need to learn a lot of the characters. We should have a Morse code stream. I feel like that would be so fun. I've already learned Morse code, but like training Morse code would be a lot of fun. There's really good like Morse code websites. I love London so much. I'd like to speak with multiple languages, but it's really difficult to just learn one. For me, like, English is already a lot, TBH. No, I'm just joking. Yeah, no, I heard that there's like a hump where you have to sort of get over, but there's also like a plateau where you're like moderate level and you can't get past really easily. Normal time, so just more uni work, labs modules. Yeah. Oh, yeah, no, all the shops are really Christmassy. I'm really excited to go to London and, like, do a bit of Christmas shopping, purchase tea and stuff like that. Soho, London. Wait, I think I've been there before. Camden Town? Camden Town. Have I been here? I don't think I've actually been to Camden Town. Let me write this down. Oh, yeah, something stochastic. There you go. We'll figure it out. The VTheorem off collab when? What? Gotta run, but congrats again. Thank you so much for swinging by. Working while studying for the master's degree is tiresome. Now have to self-study some ML for my thesis. Ooh, self-studying ML. But I feel like I'm also trying to self-study some ML as well. Just to become, like, more familiar with how it works. It's like English with German grammar. Wait, I actually really want to learn German. I heard that it's like very like building blocksy. Like the words look really long, but it's actually just like building blocks of like different like prefixes combining together to like make a really long word. I feel that's like just such a cool language idea. Camden? Okay. I guess Camden Town will definitely be on my bucket list. Compound words. Yeah, no, exactly. That was what I was looking for. German is super cool. It's like Latin with broken English. Yeah. I feel like I never learned Latin, but like when I was really little, I learned like some Spanish. I don't remember any of it. It was only for a few years. Yeah. He forgore. Yeah. Yeah, no, I'm really stoked to be traveling. But if you also think about it, it's so far. So I can't say my exact location, but I am in the Pacific time zone. So if you think about like that all the way to Europe, it's a really long flight. It's a really long flight. But I'm really excited. German law for labeling beef. Oh, what the? Sigma? What the heck is this? Wait, let me like paste this. Wait, even the Wikipedia article is like crazy. What? Wait, can I listen to it? Oh wait, hold up. Oh wait, hold up. Let's listen to it.
Rinderkennzeichnungs- und Rindfleischetikettierungsüberwachungsaufgabenübertragungsgesetz.
That is one word. Cattle marking and beef labeling supervision duties delegation law. What? 58 and 63 letters. Wait, the full name is even crazier. Oh my god. Imagine if you scroll down to the C also. Oh, like there's like these weird like New Zealand cities. Taumata, Wakata. Okay, I don't even need to pronounce this. This is crazy. Wait, let me. Oh, there's also like that one place that's like Landfair Pilgrim. Like this one. This is the name of a shipping company. Imagine just being like, yes, I work for Donau Dampfschiff Artsgeschaft. Like, that's crazy. I learned a bit of Welsh. No, Welsh is really absurd. Actually, when I was really little, like, my friends and I wanted to learn a secret language, so we tried to learn Welsh, but it was so hard. Like, all I know is, like, Hoffy Toffee or something means, like, coffee or something like that. SF to DC is, like, 5 hours flying. Actually wild. Oh, you can learn a bunch more on certain topics if you German Wikipedia. I know, it's a really long word. Longest place name in the UK. Ah, bro, some of these places are crazy names. Yeah, no, it's kind of insane. Yeah, no, I feel like one of my goals is to like go to these places and like maybe like buy like a souvenir or something. I actually heard like an issue where some of the signs in the UK named after some explicatory words got their like signs stolen. Like there's like a city like named after like the F word, I think, and they had an issue where their like signs would kept getting stolen. Germany does have a history of a lot of breakthroughs in chemistry. I know Germany also has like their own version of like NASA's Jet Propulsion Laboratory. That is one of the places on my bucket list. So my friend spent like 3 months trying to learn it to use as a secret language in A levels. Yeah, no, Welsh is hard. Welsh is hard. I think there's like an exact reason, but the grammar is different. Like the words are also really complex. Like I think the easier languages to learn in English are like the ones where the words can be quite similar. Like for Spanish, like some of the words are similar. Like time is like el tiempo, and like I don't know, that's like the only example I can think of. I took Spanish for like 3 years. Like, why can't I remember anything? But you know, there's like some similarities. Whereas for Welsh, I don't think there is. There's a small town. Yeah, no, it's these places. Wait, I think the funniest thing is always in the UK. They always have really crazy like station names. I've been seeing a lot of memes of this on my Instagram actually. Embarazada. Oh, yeah, no, it doesn't embarazada like mean like pregnant or something. Maybe. We por favor up in here. That's such, yeah, no. I'm trying to find the exact word, but yeah. The word gift in German means poison. Wait, I've heard about this, yeah. The UK is so good at naming places. Wait, I think there's like a UK like train station meme. Major train station. A pumpkin. Train station names. I've been seeing like these on my Instagram. Yeah, they're always like this. They're always like Finchley, Hendon, Wellesley, Beckton. Yeah, you know, it's like always that type of vibe. Yeah, no, the UK is great naming places. I will definitely take pictures of really epic train signs. And let me know if you have any recommendation. Anti-baby pillin as their name for... That's crazy. I've been to a train station in Germany named... What? Imagine just being like, hey, like, let's meet up at... And then it's like a 4-word, like, train station. Yeah, no, I am really stoked to visit London. HL Scandy. Oh, yeah, no, that I feel like you should just call it Scandy for short. Oh, one other thing that I need to brainstorm is a nickname for Myelin. Because you know my nickname is like Syzygy or Z or whatever you guys like to call me. CMB girl, universe girl, you know. But Myelin needs a nickname. So I was thinking like, you know, maybe something like Mimi would be cute. My. Let me know if you have any ideas. The UK is such weird place names is because the Great Vowel Shift. What is that? A series of pronunciation changes. Oh, I did not know that was an era. May could be cute. Oh, May, like, oh, that'd be cute. ZZ. I've seen some people call me like SZG, like Syzygy. Yeah, ZZ. Yeah, no, we gotta think of a nickname, guys. I have to head out, enjoy the break, and I'll see you all on the Discord. Yeah, I actually should probably roll out soon as well. But yes, everybody please stay active on the Discord. Please also go show Myelin, Phi, Psy, Nep all of the love and support. They really deserve it. They've been such an immense help. They are amazing creatives. So yeah, SCG. I've seen SZG. Zos? Zos? XUZ. How do you even pronounce that? Sausage? Oh, the Discord? Here's the Discord. Actually, what's really funny is last night, I came back home and I opened up my like photo gallery and I encountered some Among Us looking features around my institution. So my photo gallery is basically all pictures of weird Among Us characters in nature. I'll send some of the pictures I took. Red Zus. Zus? Syzygy? Zus? Syzygy. Yes. That's an amazing name. Woohoo! Zaus. Zaus. Syzygy the Y is redundant. Yeah. Among Us? What? What? Syzygy loves Among Us? What? No. I think that's like... I think you can even do like... Or is it Among Us? It was like one of the two. Yeah, there we go. There's like a whole list of commands, I think, in here. Yeah. Yeah, Southwark is not Southwark, it's like Suffolk. Oh, what's the other one? It's like... Yeah, no, but I get what you mean, yeah. Oh, I guess it's because of the great pronoun shift. Or the great vowel shift, sorry. Coolest stream ever. The coldest place in the universe. I mean, isn't the universe all at like 2.7 degrees Kelvin? So the coldest place in the universe is just the vacuum. Well, the coldest place on Earth is like the Boomerang. What? The Boomerang Nebula is 1 degree. It's even colder than me, the cosmic microwave background. It's the Boomerang Nebula, which is like 1 degree Kelvin. Wait, why? Why is it so cold? The dying star at the heart of the Boomerang Nebula squirts out a lot of gas, and these gases expand into a region of lower pressure, so it causes like freezing. I did not know that. That's really cool. The great pronoun shift. I know. I facepalm. Check the images. Oh my god. Oh my god. Wait. Wait. Maybe I can even like... Wait, I'm trying to do like the Among Us hand gesture. I guess the hand tracking doesn't work as well. But if you ever visit my hand cam streams, I do like the Among Us hand gesture. Bro, this is beautiful. New laptop wallpaper confirmed. A group I work with on campus is studying how galaxies act like heat pumps. Whoa! That's so cool. So I guess they're studying this. Well, I guess it's not a galaxy. Mercy me, that's absolutely amazing. Oh my god, that's going to be like my new wallpaper from now on. I love this nebula. What do you mean it's a stretch? It literally is so clear. You can see the visor and the legs. When I looked at that, the first thing I thought was an Among Us. I'll send some photos into Discord as well, with some of my pictures as well. Okay. It is about time. It is about time for me to depart. I'm so sad. No. Here, let me read through chat. Our group is studying AGNs. Oh, that's really cool. That's really cool. I'd like to hear more, actually. The galaxy vented. The nebula vented. What? I mean, it basically did, right? Like, it's like ejecting the gas. When I was studying electronics, I recall requesting an op-amp that could do integrals. Well, you can basically build an integrator, right? But, to do integrals is like a whole different thing. The sales guys at the store looked at me funny. Yeah. I mean, you could build an integrator. I guess there's not like an op-amp that will just do the integral itself. Thank you for the stream. Thank you, Z. Was a stream to remember. Thank you guys so much for joining. Oh, I feel so much lighter now with this, like, announcement off my chest. I have been waiting so long to tell you guys, and you guys have just been an amazing support, and yeah. I really thank you guys so much for all the support. This was a stream to remember. One of the streams of all time. No, I think this was definitely one of the top streams of all time. Oh yeah, there is a galaxy that looks like a question mark. I have seen it before. Yeah, this one. Yep. Yeah. Thank you guys so much for joining. Thank you guys so much. I'll send so many pictures from Thanksgiving, and you guys will hear so much more about all the stuff we're working on at VTHEOREM. So, alright. It's about time to wrap up. I'm so sad. Thank you guys so much for joining. I will see you guys soon, I promise. I'll see you soon. And yeah, we'll do a few more streams before the long winter break, before winter is coming. In the meantime, I'll see you guys on the Discord. I'll see you guys on Twitter, X, whatever. I'll see you guys on YouTube community. I'll see you guys everywhere. Thank you guys so much for all the support. Alright, it's time for me to dip. I'll see you later, guys. See you later. See you very soon. See you later. 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 Alright, I shall see you guys in the next one. This is me doing a heart, by the way. You can't really see it, though. Alright, VOD will be up soon, I promise. Okay. I will see you guys in the next one. Bye-bye! Bye-bye. Have a great Thanksgiving. Have a great break. See you. Bye-bye. Bye-bye. I'm August. Okay, bye.